Hi everyone. So today I want to discuss a topic which is really close to me, specifically in the development part, and that is AI assistance and AI integrations in everything that surrounds us. I feel like, especially with all the things that we get bombarded with these days, it feels really important to separate the wheat from the chaff and understand what LLMs are good at and bad at. So with that topic cleared, I want to proceed with this presentation of mine, and the agenda for today is the problems that AI can help us solve, a brief overview of LLMs and the way that we can use it, cursor AI intro, practical examples, model context protocol, which is basically a killer feature of cursor and windsurf, and also a brief conclusion. So I'll start with an appeal to authority here and say that cite Dijkstra and say that simplicity is prerequisite for reliability. This is actually a quote and basically a slide that I've used from another presentation, which is called I think like simple made easy or something like this. Really encourage you to check this out. I think I'll link it in the description. But basically, yeah, this quote and this idea will be one of the major topics of today's discussion as well. I feel like LLMs are really good at creating simple systems, but really bad at integrating different services between each other. So yeah, just try to create simple stuff with LLMs, especially in the beginning. So why do I want to use an LLM? Basically, they free me up from manual labor, and they free me up from doing the unnecessary things that I've been doing for years already. And I want to stop creating those boilerplates, and I want to offload this work to an LLM. So they're really good at converting design to code. Not even like they're not really precise at it, but they create lots of code, and for the major part of it is good enough. They're quick at replicating similar functionalities, and they're really good at recognizing like patterns and all that kind of stuff. We can use them to efficiently abstract and reuse existing logic, and they also assist me with some sort of a self review and seeing the changes that I've done in a pull request or a feature that I develop. So what are the problems that we want LLMs to solve? These are usually high effort, high time consumption, and high repetition tasks, such as moving files around or like downloading assets from Figma, maybe searching the web for some additional documentation about the specific feature or a module that you're working with. And also low complexity, low impact on the system, and low dependability. So these are usually some sort of isolated modules, components, really stateless or sometimes stateful, but really like a simple and clear logic, and also like layouts and working with some CSS or maybe some stylistic updates to your application. So these are basically the examples of the things that I want to offload to an LLM. We see the layout on the left. I think, this is really one of the best examples of what LLM can do. Surely this example uses ShotCN components, but creating layouts and like recomposing an already existing library and different components there is perfectly fine for an LLM, even if it doesn't get it quite right from the first try. Usually, I don't know, like around 80% of the code it generates is good enough, especially if you're using pre-built components, which are already great. So yeah, creating layouts is one of the best things that LLMs can do. There's also a video player here. So really creating a video player, I've done it in production, and we're using it right now. This is a really nice example of a video player which is really simple. It doesn't have like all the complex pre-buffering logic and maybe some additional and specific features that a built players would have, or something that you would find on an npm with lots of downloads. But really creating something simple and easy is pretty much doable for an LLM. And also a more sort of a complex example than just a layout. I have a stateful component of a camera where I'm basically streaming a stream to a canvas, and then capturing that onto a canvas and like downloading, say, given image in a blob or something like this. This is perfectly doable for an LLM. Again, it might not be the best and the cleanest code that you've ever seen, but this is completely, like I said, doable for an LLM. What tasks are LLMs are bad at? So this is usually concerning the fact that LLMs generate too much code when they do a solution. The logic that they create is usually unclear and confusing, and this is something like a junior developer would do. But I would argue here that this is usually not the code that you want to see in your code base. But if this concerns some isolated modules that you won't even touch for like months to come, uh, often you can kind of ignore the fact that the logic there isn't as clean and just like let it be there. The solutions that the LLMs create are often ambiguous and not really clear, and they're often using like the simplest logic, but like there's just a lot of it. Say like if you're writing React code, it will use like a number of use states instead of using a single use reducer or I don't know, some more efficient solution. It can have hidden and complex bugs. It can have like incorrect or inefficient solutions, but I would say that here it usually concerns tasks that are just too difficult for an LLM to handle. It can have like different mistakes and hallucinations, especially if you're working with some modern code that this specific LLM hasn't seen and you haven't given an access to some external tools for this LLM. And yeah, like I said, it's trained on outdated examples, so usually the model that you're using has a like a delayed training date of like 6 months or maybe even more than that. And what are the tasks that you want to keep an LLA away from? These are usually high in predictability, high flexibility, high precision, low effort, or low repetition tasks. So these are like your project configs, working with some core modules in your application, API schema design, something that you create from scratch. And really, these features are often best handled manually, and often these features are the most interesting in your application. So why would you even want an LLM to solve it? Anything that requires precise changes, especially when you're working with some library or a framework, usually LLMs are not quite good at changing the system precisely, or changes that span across your whole application. Also, new releases, like I said, LLMs are really bad at using the up-to-date information. There are some tools that you can use to mitigate this downside, but still, like usually these things are best handled manually, especially given the fact that most of those major libraries have some code modes and migrations aren't really that complex. If you do them one by one and you're like not migrating like React from 14 to 19, for example. So yeah, I feel like it's kind of necessary to mention the LLM training process. Basically, what they do when they're getting trained is model gathers some data from the internet, or not really a model, but the researchers or the people that train this model. It goes through some training steps, and then you have basically the remixes of the training data that are being filtered by the reinforced learning step, where basically some instructions are given to an LLM and it kind of embraces some sort of a personality. But in code and specifically in some other areas which aren't really that verifiable, it's really hard to differentiate good and bad code or like good and bad solutions, because like verifiable metrics of like does it compile, does the project build, are there any errors in the console, or maybe like your lint errors aren't always the mark of a successful solution, or like things that a senior developer would do, right? Sometimes even things that don't have any errors still contain bugs. So unfortunately, these metrics are really far from the quality standards that software engineers operate with. But why do I still want to trust an LLM with a task given the fact that we have these downsides? Basically, I trust it because I want to offload work that even if it does with some sort of an error or it has like a percentage of an error, it still would be fine and it still wouldn't break the application, and it would be easy enough for me to step in and do the rest of the work, the rest 20% of the work. Yeah, like it says, LLMs has a large data set of code that's good enough. I think that if you're creating some sort of a layout or a React component that is somewhat dumb, you can still use an LLM perfectly fine. Basically, I want LLM to handle tasks that are hard to fail and easy to succeed at. And if it even if it does fail, it will be easy enough for me to kind of do the manual change after that. So this is basically the summary of the first chapter. I covered the tasks that I want LLM to handle and those that I want to keep away from it. And why do I still choose to trust an LLM with these tasks? So yeah, this second chapter is basically about Cursor IDE and the Model Context Protocol. We'll cover the major features of Cursor, which are code completion, which is basically your copilot, but it just works better. Agent mode, model context protocol, and this is a VS Code fork. So all the extensions that you're used to, or all the things that you are working with in VS Code, should work in Cursor. I think I've tried NeoVim, and this didn't really work with Cursor. I feel like there are still some workarounds about that, but kind of ignore that. So yeah, models. I'm usually using Claude 4, especially since it's just recently dropped. Before that, I was using Claude 3.5, 3.7. I didn't really see that major of a difference, honestly, but still kind of nice to use the latest model, I think. And Claude is basically the go-to solution for anything that concerns code. So, and this is what majority of programmers use. So I just choose the winner here, basically. Gemini 2.5 is great if you want to work with a large context or just want to analyze some sort of a feature that spans across your whole application, and you just wanted to collect like as much of an information about this. GPT 4.1 is here for just one single reason, which is V0 model. It only works with GPT 4.1. It doesn't really, it's not really supported by Cursor natively. There's just a like some sort of a workaround about that, so I just have it in the list there. There's also the max mode, which is a mode that allows you to basically run your models for dollars instead of like using the Cursor subscription. These models are usually like I don't know, they're just bigger. They have more parameters, but I feel like this isn't really the tasks that I want LLM to complete. So I'm usually using Claude 4, and that's it. I'm not even using the thinking versions. Not really much of a benefit, I feel like. So yeah, the first feature is code completion. Basically, Cursor is great at analyzing the context and kind of guessing what you want to do with your form or your like code ahead. We have an example of a middleware, a couple forms here, some DTOs for authorization and authentication. So I feel like these are great examples of what it does. Then we have the agent mode. There are two options there. Basically, you can have an ask or a agent mode. The ask option just lets you basically um, get an analysis of a feature, and this is an example of that. I'm asking Cursor to basically analyze a module and understand what it impacts. But there's also an agent mode that allows you to kind of ask the LLM to make some changes in your code. We have built-in tools. I think one of the major here, which are kind of worth well to be mentioned, are files and folders. Specifically, you can use that to like limit the context of a model, which is really means a lot, especially with models that have limited sort of a limited amount of tokens that they can process. So yeah, and really the smaller the context, the more precise the changes and the solutions would be, unless model doesn't really know what the other parts of the application are, and just you're just asking too much of it. There's docs and cursor rules. We'll cover them a little later. But basically, docs are about the specific instructions that your project has and the instructions that you want LLM to follow. And rules are just like a personified guidelines for your model. So yeah, this is an example of a docs, which is basically uh, asking or like ordering the model to follow some specific rules and create features with some specific solutions. And the rules are, like I said, basically a personification of your model. This way, you can ask it to format the responses in some certain way, or just provide the responses in some structured order. We have the inline edit feature. I have almost never used that. I find it really easier to make the change manually and then kind of tab my way through it because it, like I said, the code completion works perfectly fine here. So yeah, not really much to say about this feature. We also have the bug bot, which it has just recently dropped with Cursor version 1.0. Previously, they had the bug finder feature, which they have deprecated. So, in my opinion, all those solutions that allow LLMs to kind of do reviews for you aren't really that great. Most of the suggestions are redundant or just use some outdated information or aren't really that specific or precise. And usually these are just like bloated pieces of suggestions or code in your PRs or even in your IDE. So I have used CodeRabbit in production extensively, but I have since disabled it completely. Yeah, I don't really find any use of that anymore. MCPs. So yeah, basically this feature allows Cursor to use external tools right in your IDE, essentially creating like a streamlined experience of integrating some external APIs right in the chat of your IDE. One of the prominent ones is Figma MCP. I covered it in my previous video. Basically, it allows you to convert design to code real easy and simple. There's just one drawback, I think, here. The first solution that you get from the Figma MCP is usually the best one. It doesn't really help to ask it to like modify it or like download the assets again or like be more precise or specific when it kind of converts the design. Kind of helps to provide the MCP with an image, especially now you can provide screenshots right in the chat. So yeah, this tool I'm using it almost every day, especially when I'm like converting design to code. Really helps with creating the initial layout and downloading the assets. Like I said, I really like it for offloading the manual work that I would do by just going through each of the assets in the Figma and like putting it in my project folder. So this really helps with that. Playwright MCP, I have also covered it previously. I'm not creating Playwright tests yet, but if I would use this tool. Really clear and simple use case. It's supported and like maintained by Microsoft. So I feel like this is one of the core features. If you're working with a Playwright, I'd really love to hear your feedback on that. Stage-wise, basically a tool that allows you to make some precise changes in your application in the UI, which really helps if you need to do some minor changes to the layout or maybe like the components that you use there. So as an example, I have this Excelidro repository and project open. You have this some sort of a chat window in one of in the left corner here. When you press and enter the chat mode, you can select the components on your UI. These are basically highlighted in green. So yeah, when you have done selecting the components, you can enter a prompt. This prompt will be passed to your IDE. It will do some changes there, just like if you would enter this prompt in your chat, but it just kind of passes the specific nodes and it finds the components from the UI to the code and does it really great. Haven't really used it that extensively, but I'm really excited to be using this feature more. Cursor tools, I have already covered it previously. Really helps with repo analysis or some like feature analysis or a module check, especially if this is some sort of a new repository or maybe some feature that you haven't really seen before. It has the it has support of all the major models and especially the Gemini with 1 million tokens. So if you're working in some large repository and you need to analyze a large module or a large folder, this really helps. And also context 7 is worthwhile to be mentioned here. Basically, the context 7 contains up-to-date documentation about all the major libraries like React, Nest, Next.js, and it really helps to kind of refer to the up-to-date documentation instead of your model searching the web and trying to parse all the web pages. So yeah, like I said, it really helps. Yeah, this is the summary for the second part. We have covered the cursor IDE, its basic features, the configuration of that, and also have touched the model context protocol features and basically explained one of the major tools that I'm using alongside this solution. The third chapter is risks, pitfalls, and damage control, which is basically me explaining my experience with LLMs working in production. So yeah, a rule of thumb here is if you don't know how to develop the feature or a module or how this specific piece of code should work, don't let the LLM create it for you. Um, there's this popular myth of vibe coding, which is basically in an idea that covers a process of like you can just prompt your way through a feature and never really write any line of code by yourself or like manually. You just prompt your way through and then you deploy this feature. This in my experience, this quickly leads to prompt fatigue, really bloated code base, ambiguous code, totally unclear solutions, and your teammates not even understanding how this feature works. So these are the usual suspects of failed LLM implementations or like tasks that are just too complex for an LLM to handle. And this is usually concerning over-prompting, over-complicated tasks, or vague instructions or bloated context. Basically, these three are the reasons why an LLM could fail at a given task. So over-prompting usually starts really easy and simple. You have a prompt and a feature that you want to develop, and it almost works from the first try. And the reason I have this casino image here is basically because it really feels like a casino. Because you've just like you've entered the prompt and 5 minutes later you almost have it ready and you're just like all happy and stuff. The second part here is you continue to prompt and the feature still doesn't work. It still lacks some functionality. There is still something missing, or maybe with every prompt, some parts of it get worse and some parts get better. But still, you can't really make sure that this is something production ready. And all this time, while you're prompting this, you really don't have a clue how this feature is working. And the third step here is you're homeless. Basically, you're out of job and you were fired because you couldn't deliver a feature to production in time. So really, when this situation happens, and I feel like it really you can only learn from experience here. I hope that you're not losing your job on the first try though. Really, you have to develop a gut feeling of tasks that are doable by an LLM or tasks that are too complicated for it. And it really makes sense to go back to this first step and understand and kind of try to analyze it. So really, yeah, like I said, take a step back and think if this feature is something that you would want an LLM to implement. If you're still sure about this, try to set a max time or attempts for this feature. Try to limit the context as much as you can. Try to like split it into subtasks maybe, or do some changes manually. Be as specific as you can with your prompt. Uh, Again, like I said, like try to limit the amount of work that LLM has to do here. And if it still doesn't work, you have to do it manually. It would, I promise you, it would just be easier if you have done it manually. You wouldn't get as much stress as you would just by prompting and hoping for the best to kind of come. Another thing here is overcomplicated task. Basically, these features are something that spans across your whole application. Just a feature that is too complex for an LLM to handle. This is usually the chart of working with an LLM and a chart that explains the whole process of a feature that you develop using an LLM. So you have this prompt. It almost works on the first try, but there is just some critical issue with it, and then you prompt it again, and there is still something that this feature lacks. You prompt it again, it creates some more bloated code, and you just realize that this feature is totally unmaintainable, and any new like instructions, any new business requirements aren't gonna be supported by this feature, and it really becomes too complex to maintain. You cannot really understand the logic of it. You cannot do any changes manually because like the whole solution is just too fucked up at this point, and there's a high chance that you would need to refactor and rewrite this solution on your own. And also another thing is a task where you're given bloated context to an LLM, or this feature just has too many moving parts. Like it says, usually these things span across your whole application. These are your like authorization modules, analytics, some sort of an event management, some pops up, sagas, whatever. Something that is just too complex, and there are too many moving parts for an LLM to kind of grasp and understand and deliver a precise solution. Yeah. So what is the cure for these situations? Basically, you need to research and read the documentation for the feature that you want to develop, especially if you're working with some sort of a library that is complicated enough, like a I don't know, like React query, or again like React, some new modules, new hooks, new versions of it. Maybe you're trying to deliver a like a server rendered application, and you want some precise things to happen there. These things are usually best delivered by hand, especially because you will be working with this application, and you need to understand the initial configuration, the initial structure, the architecture, the solution, and all the moving parts in this application. And yeah, as a result, you get an ability to predict potential failures. You understand the limitations of this feature. You're better at predicting the necessary things that need to be done if new business requirements arrive. And yeah, basically, you know all the ins and outs of this feature or your application, and you're the guy that could like analyze and understand what things can be done or cannot be done, and predict how much time would be needed for the new feature to be implemented. And this is a summary for the third chapter. We covered all the major problems that I've experienced and the things that I have dealt with personally in production code in projects that I've been involved in. And we covered typical problems with LLM generated code and how to deal with those problems. And that's it for this presentation and this video, I think. Yeah, I would like to say that working with LLMs is really great. They're great at helping you with some simple tasks and helping you with offloading some manual work and basically getting you free from doing all the boilerplates and all that stuff for the thousandth time. But still, you have to remain creative and remain interested in the craft that you're involved in, and you have to develop on your own and kind of leave the LLM to do the dirty work for you. And yeah, that's it. Thank you guys. Bye.